Okay, this is for section 6.6 on rational exponents. When you see the word rational, okay, that means they're going to be, the exponents are going to be in the form of a over b. Okay, so you're going to get rational or fractional exponents. Okay, so first I'm going to go through the definition, then we'll go through several examples. Okay, for any, use the double bar R for real number. For any real number, and they're using b, and any positive integer meaning when they use the word integer, they're saying 0, 1, 2, 3, dot, 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 negative 1, negative 2, negative 3. And any positive integer in b, and be careful with your own handwriting, b to the 1 over n power. That 1 over n is a power. It's b to the 1 over n power, okay, equals, sorry, that should be an equal sign, equals, the number in the denominator is the index. So you can write it the nth root of b, and it's actually the 1, the numerator can be written on the inside or the outside. So if you have b to the 1 over n power, that denominator is your index. It's the nth root of b, except when b is less than 0, when b is negative, and n is even. And the author puts a little disclaimer in the book: when b is less than 0 and n is even, a complex root may exist. So in other words, they're saying you might end up with an I value. So they will give you problems like this: 8 to the 1/3 power. Okay? Don't let the rational exponents scare you off. If you're in exponential form, you go to radical form. If you're in radical form, go to exponential form. So we want to go from exponential form to radical form. The number on the bottom, or the denominator, is the index. So it's the cube root of 8, and it's actually cube root of 8 to the first. You don't have to write that 1 down. I usually don't write it down. So you'd say cube root of 8. Cube root of 8 is cube root, not cube. Yeah, so you have to say what number times itself 3 times to give you 8. So 2. Okay, another example: 25 to the 1/2 power. You're in exponential form, so you can go to radical form and say that denominator is the index, so it's the square root of 25. And when they're doing the square root of 25 like this, they're doing counting just the principal nth root, so they're just counting the 5. If they did something like this and they put x squared equal 25 and took the square root of both sides, then they're considering positive or negative. Okay, but if it's just square root of 25 by itself, they're considering the principal nth root, and their answer would be just 5. Okay? For any non-zero real number, use a double bar R. For any non-zero real number b, and any integers m, m and n with n greater than 0, sorry, greater than 1. That's my mistake. With n greater than 1, b to the m divided by n power, the rational exponent is m over n, equals the number in the denominator is your index. So it's the nth root of b. The number on top, if it's something other than a 1, that m can go on the inside, okay, or it can be written as the nth root of b, and the m can go on the outside, okay? Except when b is less than 0 and n is even, a complex root may exist. That means you might have an I value. Okay? Okay, so examples. Say I give you 8 to the 2/3 power. Okay? 8 to the 2/3 power. If you're one of the, and I've said it 2 times now, this is the 3rd time. If you're in exponential form and you're stuck, you go to radical form. If you're in radical form and you're stuck, you go to exponential form. So we're in exponential form. So go to radical form. So the index is the number on the bottom, and it would be 8. And then you could go the cube root of 8 squared. I'm going to show you 2 ways to work this. You could put the 2 on the inside, and you'd say the cube root of 64. Cube root of 64 is 4. Okay, or you could say the cube root of 8, and then the 2 could go on the outside. So cube root of 8 would be 2, and 2 squared would be 4. So either way, you should get 4 for your final answer. Okay? Okay on that one? Okay, another example. So you have 32 to the 2/5 power. And you do have to be careful of your handwriting so it doesn't look like, there's a difference between 32 to the 2/5 power and 32 and 2/5. Yeah. Be careful of your own handwriting. Okay, so on this one, you do the 5th root of 32, and I'm going to put the 2 on the outside. What number times itself 5 times gives you 32? What'd you say? 2? Yes, 2. 2 times 2 would be 4, times 2 would be 8, times 2 would be 16, times 2 would be 32. 2, cube root of 32 is 2, 2 squared is 4. Okay? Okay? Okay, then the author is going to introduce what happens if we have 49 to the negative 1/2 power. Now, if you have a negative rational exponent, that negative sign has got to go up with the numerator. Okay? Because you're never, ever going to have a negative index. Or this part, this is what I'm calling the index. That's never going to be negative. Okay, so on this one, you're going to say it's the square root of 49, and that's to the negative 1 power. Square root of 49 would be 7. 7 to the negative 1 power, nope, would be 1 over. All that's going to do is move that 7 down to the denominator and make it a positive 1. So 1/7 should be your final answer. Okay? Got to be careful with the negative powers. Okay? Let's try another one. Let's say you have 64 to the 2/3 power. Okay, so that'd be the cube root of 64 squared. Cube root of 64 would be 4. 4 squared, 16. Okay? Okay, then, okay, you can also take and split these up. If I said b to the n divided by n power, I can split that up into b to the 1 over n and raise that to an n power. Because when you raise a power to a power, what do you do with the exponents? Multiply them. When you raise a power to a power, multiply them. Like if I did x to the second to the third, it'd be x to the sixth. Okay. If I did an x to the second times an x to the third, that'd be an x to the fifth. Okay. You can also write this as b to the n power and raise it to the 1 over n power. Because either one of those, you can split it up either way. Okay, because you raise a power to a power, you multiply them. Okay. The next thing the author has is simplify expressions with rational exponents, and that means apply the laws of exponents. And any, we said it up above, any exponents in the denominator of a fraction must be a positive integer. Okay, so they will give you problems just like we've had before, but now they're going to use rational exponents. So, example, if I said simplify y to the 1/7 power times y to the 4/7 power. Okay, when you multiply monomials and the base is the same, what do you do with the exponent? Add them. So 1/7 plus 4/7, 5/7. So it'd be y to the 5/7 power. And that's as far as they are asking you to go. Okay. If they gave you x to the negative 2/3 power, okay, they're basically saying split this up so you have two quantities divided, and the one on the bottom has to have a positive exponent. So what they're doing on this is they're saying x, split that up into x to the 1/3 divided by x to the first. Because when you simplify that, what's 1/3 minus 1? 1/3 minus 3/3 is the negative 2/3. So they're saying this has to be positive. Okay, any exponents in the denominator have to be positive integers. Okay. Okay, let's try a couple more. So we have just to simplify, and that's usually in the directions. That's all it will say is simplify. The 6th root of 16 divided by the cube root of 2. If you're in right offhand, I can't think of anything 6th root of 16. So if you're in radical form, you go to exponential. So the 6th root of 16 would be 16 to what power? 1 over 6. The cube root of 2 would be 2 to the 1/3 power. Now, the little trick to this is you need these two bases to be the same. Much easier to go smaller. So 16 is 2 to what power? Yeah, 2 to the 4th. So I can write, you might make a note out at the side at this point. You're trying to get the same base, and probably want to get the smaller one. So 16 I can write is 2 to the 4th, and that is still to the 1/6 power. This is still 2 to the 1/3 power. When you raise a power to a power, what do you do with the exponents? Multiply them. So that is 2 to the 4/6 power. This is still 2 to the 1/3 power. Reduce 4/6. 2 to the 2/3 divided by 2 to the 1/3. Now your bases are the same. You're dividing monomials. When you divide monomials and the bases are the same, yeah, you subtract the exponents, so 2 to the 1/3 power. Okay? The whole key on this is you're trying to get these two bases to be the same and work to get the smaller one. Okay? Any questions on that one? What's that? No. No. Are you thinking divide those out to 1? Think back. Go all the way back. That's a good question. Go all the way back. Let's say you did like x to the 3rd divided by x. Is that answer 2? No, you'd say x, like you divide these out, right? Those divide out and you have x squared, right? The base stays the same, and then you subtract the exponents. Okay? And that's a good question, and that is a common error. So, okay. Okay, another example. Say we have the 4th root of 32 divided by the cube root of 2. Okay, and another thing that you may want to write down, you're in exponential form. I know the 5th root of 32 is 2. 4th root of 32? Nothing coming, and I don't want to go to the calculator. Okay, so you're in radical form and you're stuck. Go to exponential form. Those ought to be two things that you're working on in this section. If you're in exponential form, go to radical form, go to exponential. So this one you want to go 32 to what power? To the 1/4 power. And 2 to the 1/3 power. And common base, 2. 32 is 2 to what power? 2 to the 5th. And raise that to the 1/4 power. This is going to stay 2 to the 1/3. Raise a power to a power. Yep, 2 to the 5/4 power divided by 2 to the 1/3 power. When you divide monomials and the bases are the same, subtract them. Common denominator, 12. Multiply this by 3, multiply this by 3. Multiply this by 4, multiply this by 4. 11/12. So 2 to the 11/12 power. So yes, you may be working with some fractions. Okay? Okay? Okay. Stop there.